non-aqueous solvent, it is strongly recommended that you must take acidic solutions or basic solutions. Means you have to add CH3COOH or you have to add ammonia to dissolve the compound, because acetic acid is a very weak acid and ammonia is a weak base. So only weak acid and weak base are to be added to the solution to make it ionized, and then you can do titrations. Examples given here: a weak acid or a weak base, A minus plus H2O. A minus the conjugate base of an acid HA plus water, it gives rise to HA plus OH minus. Then pK of HA is nearly 7. The basicity of A minus is considered high. Okay, this is not so important. You can see this is the titration curve of a weak acid or a weak base. The difficulties encountered in the titration of dilute solution of a weak acid with a alkali solution can be summarized as this. The influence on the pH neutralization curve is small. The phenolphthalein color fades away at the end point and interference due to atmospheric carbon dioxide. Okay, this much you remember. What are the difficulties you may face when you are preparing uh, while you are doing titration of a particular compound versus uh, a compound prepared in non-aqueous medium. Three things are there. The inflection of pH neutralization curve is small. Then phenolphthalein, when we are adding phenolphthalein for changing for visualizing the end point, then it may fades up immediately. Then atmospheric carbon dioxide may interfere the reactions. These are some drawbacks of the titrations in non-aqueous medium. Acid-base reactions in non-aqueous medium means you are not using water. Role of solvent in acid-base reaction. You can see here RNA's concept is there. Role of solvent means, for example, you have taken one compound NH4OH and then you are adding water. Then from water H plus ion and OH minus ion, the water will take H plus ion from ammonia. So ammonium ion will donate a proton and it gives rise to ammonia and water. So you can see the reaction: ammonia plus water, NH4 plus OH minus, ammonia plus HCl, NH4Cl. So these two reactions you can see here, that these two reactions when took place simultaneously, and their values you can see here. Titration values are given here. Solvent is ammonia, liquid ammonia, it is non-aqueous solvent. H2O is aqueous solvent. C2H5OH is a non-aqueous solvent, and benzene also non-aqueous solvents. So you are using acid 1 and base 2, acid 2 and base 1 reactions. So in the reactions of acid 1 and base 2, the solvents are ammonia, water, H2O, all alcohol, benzene, like this. And remember one more thing, that uh, that when you are using different solvents like isopropyl alcohol or ethylene glycol or acetic acid, then remember the indicator is phenol red, because depending on the solvent, indicators are different. Similarly, nitromethane or acetic anhydride, very weak bases, for that you have to use methyl violet or neutral red. So remember these things, that there are different types of indicators are there. In different medium, you can use them. So, ସମସ୍ତେ ଗଲେନି କି ଅଛନ୍ତି ଆଉ ଆଉ ଅଛନ୍ତି ଠିକ ଅଛି so okay the next one is you can see here solvent systems are there. Solvents may be amphiprotic, may be aprotic, may be basic, but not acidic. So as I told you, the solution non-solvents are different types: amphiprotic, aprotic, basic, or not acidic. Then these solvents are used due to titration processes, and you can see one weak base like pyridine is also used to titrations. So these are the equations, not so much important for all of you. For protophilic solvents, photogenic solvents, these things you have to remember only the definitions. See, here definitions are there. Aprotic means these are neither appreciably acidic nor basic. The inert solvents, sometimes called benzene, toluene, petroleum ether, carbon tetrachloride, these are called as the aprotic solvents. These are called as the aprotic solvents. But when you are using like aprotic solvents are neutral, chemically inert. Benzene, chloroform also used as aprotic solvents. Uh, Similarly, if you are using protophilic solvents, then they are basic in nature and react with acid to form solvated protons. Examples examples are given, not given. Oh yes, perchloric acid. Perchloric acid is an example of protophilic solvents. Similarly, protogenic solvents is sulfuric acid. They are acidic substances. They exert a leveling effect on the bases. Then basic but not acidic. These type of substances are example ether, dioxane, ketone, pyridine. They are basic but not acidic. These are different types of solvents used during acid-base titrations. Then Hammet's acidic functions. These are formula-wise given only, not required in this case. Titration and endpoint detections. During titration, for example, perchloric acid, titrations in presence of acetic acid or non-basic solvents are carried out by using perchloric acid as a titrant. It is a strong acid and it's easily available. Many other strong acids may also be used. Then what is so advantageous about using the perchloric acid? This question will come. The reason is primarily that in acetic acid, chlorochloric acid gives a longer potentiometric break. Means your graph, you have seen the graph. These are called potentiometric graphs. You can see these are potentiometric graphs. These graphs, if they give longer break, then easily you can identify the endpoint. You can easily identify the endpoint. Endpoint. In a longer break, then nitric acid also. So endpoint is very much visible during the titration process. Therefore, remember that the endpoint is visible, then only the kinetics of the reactions can be measured, and you can also analyze the data from the titration curves. Similarly, for alkali metal bases, what to do? Quaternary ammonium hydroxide, what to do? All these things are there. Titration of halogen acids of bases. The halide ions are quite weakly basic, so they cannot react with acetous perchloric acid. This is a very not. These are the curves. These are the potentiometric curves. You can see potential on the y-axis and percentage utilization on the x-axis. You can see here the pKb value of aniline 9.4, para-bromoaniline. You can see ortho, para, these are the substituted anilines, and the pKb value is also increasing when they are substituted ortho and para positions. They are due to inductive effect and resonance effect. These are the breakpoints. These are the breakpoints. You can see the red line. Breakpoints are there. These breakpoints are very much essential to indicate whether the titration has the end point has received, the end point has obtained or not. Some applications. Correct pH condition are to be maintained in manufacturing process industries. You will also have to check the acids and bases in reactants as well as the products. If you have to work in a food, petroleum as well as beverage industry. So if you are working in food, petroleum or beverage industries, then maintenance of pH is very important, and the reactants what you are using, products what are formed, all these things are to be very much um, analyzed before doing any practicals. Therefore, Geldal's method, you know Geldal's method, Lasaisen method, they are the methods used to determine nitrogen. So it is there also. So in Geldal's method, it is a pharmaceutical industry, it is very much required in drug analysis. And Jitendra, you are working in which company? Hello, Jitendra,
Yes, sir.
you are working in which company?
I'm in Chemi Product Limited.
Chemical.
Chemi Product, ये color बनाती है polyurethane color.
In a chemins, when which type of products you are preparing, or it is an industrial or manufacturing industry.
Manufacturing industry.
Okay, okay. Then this is very important. Titration is very important. pH is very important. Yes or no?
Yes, sir. We do hydroxyl value and acid value.
Yes.
I check hydroxyl value and acid value and OH
Uh,
value.
so you are what type of instruments you are using?
I'm HPLC, this thing.
One potentiometry, you know potentiometry.
pH meter.
You say pH meter. It is nowadays more used. So the endpoint can be measured easily, and secondly, the pH value does not vary so much. But again, if the environmental condition is something different, then pH also it will change. For example, the solvent, as I have discussed, you solvents. If non-aqueous solvents and aqueous solvents, they will give different pH. Because as you know, aqueous solvents means you have H plus ions, so pH will vary. Okay. Then some questions are there. Hey, see, these are the main questions will come. What is amphiprotic? What is non-ionizable? What is aprotic? The benzene, chloroform. These are all aprotic solvents. The equations are not will come us. These are simple things they will ask you. They are very interesting questions. Just have to write this thing. Okay, conjugate acid, conjugate base. I told you to get conjugate acid, you have to add H plus. To get conjugate base, you have to subtract H plus. And see the precautions to be taken during iterations like this. Okay, next units will go. Unit Jitendra, you have unit 10 downloaded in the e-Gyan course or not?
Sir, seat not visible.
Hello?
Yes, sir.
If you have, can you send it to me through WhatsApp? No, it is not now downloaded on the website at present. Don't know why. Net is there, but it is downloaded why. Don't know.
I have downloaded.
Now just I will try again. Again I should try it. I think it's possible now. No, it is not possible to download. If you can, you have na?
E-Can course? Yes, sir.
E-Gyan course. Can you type MCH-1, MCH-001? It is not coming now. MCH-001. This one. Why it cannot reach? Why I don't know why it is like this.
Unit 8,
Hello?
Unit 6 या 7, 8.
नहीं नहीं इसका यूनिट ना यूनिट 10 10 10
10.
यूनिट 10 11 12 13 14 this much remains 10 से 14
redox reaction.
हाँ 10 से मुझे भाई यूनिट 10 चाहिए
हाँ सर, है मेरे पास.
हाँ और 10 से 14 तक मुझे भेज देंगे आपके पास मेरा नंबर है कि नहीं
नहीं सर.
लिख लो 7978 1498
797814.
9856 Rajesh Kumar Sahu just send this only these portions unit 10 to unit 14 last yesterday I have downloaded it but it is not there in the computer and now it is not going down I don't know why
I sent sir.
you have sent yes thank you okay now you can able to see yes
No sir.
you can able to see it okay 1 minute now you can see
Yes sir.
okay okay redox titration redox itself it means oxidation reduction taking place simultaneously and this is a very important thing in chemical also in the industrial metal industries because many reactions takes place due to presence of oxygen because when the reductants when oxidants are there in the atmosphere so many reactions are redox reactions and first of all simple things to remember that the loss of electron from any atom to for a positive ion is equal to is called as the oxidation. Loss of electron is oxidation, gain of electron is reduction. Fe2, or you can say increase in oxidation number. Fe2 plus Fe3 plus Y, there is an increase in oxidation number. Then also it is called as the oxidation. Similar decrease in oxidation number, you can see Cl2 plus 2E, 2Cl minus. Means you can see the oxidation number from 0 to 0 minus 1, it is decreasing. So decreasing oxidation number is reduction, increasing oxidation number is also called oxidation. And you can see simultaneous reactions, cerium plus 4 to cerium plus 3. So it is decreasing, and Fe2 plus to Fe plus 3 it is increasing. Hence the reaction is called the redox reaction. And two half cells are there, you can see. First half cell Fe2 plus to Fe3 plus, loss of electron, 1 electron, and cerium plus 4, cerium plus 3 again. So when you add these two reactions, then it will be balanced. For example, in a reaction you have 2E and 1 is 3E. Then 2 and 3 LCM is 6. So you have to multiply in such a that all the electrons will cancel on both sides. Then only you can get the balanced redox reactions. And you can see here the atom which is oxidized is called oxidizing agent. The atom which is reduced is called reduced. Means anything which helps in oxidation is called as the oxidizing agents. Which helps in reduction is called the reducing agents. So always remember that Fe2 plus to Fe3 plus, Fe2 plus is oxidized to Fe3 plus. Then remember, in any chemical reaction, like redox reaction, there is a change in potential difference, called as cell potential. Sometimes we call redox potential, sometimes we call as the anodic potential, then we also call it cathodic potential, but in general, it is called as the redox potential. Means the difference in the potential of the oxidation half cell and the reduction half cell. You can see here, if you have if you want to see what is called standard electron potential, then you can see you have an like platinum, then you have hydrogen electron, then iron 2 plus or iron 3 plus, then platinum. This is called as the standard redox potential to calculate the potential of iron, only iron, because you know H plus and H plus or H2, the potential is 0. So whatever the potential it will come is the potential of the Fe2 plus to Fe3 plus. You can see here also that Fe2 plus to Fe3 plus is simply an example of what? The example of oxidation. Fe3 plus to Fe2 plus, because there is a decrease in plus 3 to plus 3. It is a minus, it is a gain of electron. It is called a reduction. So Fe3 plus to Fe2 plus is a gain of electron, is a reduction reactions. And here potential is there also, negative potential will be there. Similarly, you can see fluorine to fluoride ion plus 2.65. Then H2OA 2 minus to SO4 2 minus, it is plus 2.01. These are the potentials called redox potentials calculated basing on the hydrogen potential, which is called as the standard electron, is called as the reference, or you can say normal hydrogen electrode. Its value is 0. So if you are connecting two electrodes, one is the hydrogen electrode, one is the iron 3 plus to iron 2 plus electrode, means reaction electrode, then the difference in potential will provide you called as the redox potential. You can see some value redox potential given below. All these values are calculated basing on the reference electrode, that is hydrogen. You can see it here. Then you can see many reactions are there. They are all redox reactions. You can see here the redox reactions are there. Then electrochemical cell. Remember, electrochemical cell is based on redox reactions. You can see here two beakers are there. Zinc electrode, zinc deep in zinc sulfate, copper in copper sulfate. This salt bridge. And this salt bridge maintains the electrical neutrality of the solution. We have voltameter and like these things. So this experiment, you can see zinc to zinc 2 plus oxidation, copper 2 plus to copper reduction. It is a complete redox reaction, so you can see here. The potential can be calculated by Nernst equation. E is equal to E0 cell minus RT by NF ln concentration of metal by metal ion M2Mn plus. Then similarly, you can also calculate in this manner also. And you can see one example, copper 2 plus 2E copper. The next equation is E copper 2 plus by copper. E0 copper 2 plus by copper minus 0.059 by 2 log 1 by copper 2 plus I. This question will come definitely. Exam में question आएगा electrochemical cell. This will definitely come. You can see then cell potential, then you see that then first half cell is copper, copper 2 plus copper 2 plus slash copper. Next one is 2H2 slash H2. It's a potential is there. Then you can differentiate the value and you can calculate cell potential. So you can see the reaction cathode, reaction anode, then E cell equal to E0 cathode minus E0 anode in terms of reduction potential. Both the equations have been written here, subtracted to get the result in this way. E cell equal to E0 cell minus RT by N ln, then zinc plus 2 concentration by the copper plus 2 concentrations. For example, you have an equilibrium reaction like AB, AA, BB, CC, like NE, CC, DD like this. The next equation would be like this. E is equal to E0 cell minus RT by NF. You can see it there. You can see it AA plus BB plus E is equal to E0 cell minus RT by N log concentration of C, मतलब product concentration to the power their term CD and AA BB. And here if you put the value RT N, it comes to be 0.091 by N. RT and F 0.091 by N is a fixed one, and the number of electrons, the number of electrons those changed during the redox reactions. For example, it is a copper 2 plus 2 copper, and then Fe2 plus, then it is N equal to 2. You see here nickel 2Ag plus, nickel 2 plus, and 2Ag. You can see 2 electron, and here N equal to 2. And the cell potential is found to be 1.05 volt. So if it is positive value, then it is the reaction is feasible. If it is negative value, the reaction is not feasible. You can see here. Many reactions are given here. Redox equilibrium constants, everything is given here. And also you can write in terms of the equations like this. If you have two different types of N1 and N2 are not equal, then you can write log K is equal to N1, N2, E1 0 minus E2 0 by 0.05. Depending on the reaction, different types of reactions, you can put the value to get the equilibrium constant. Redox titration curves. Okay. Not so much important, but you can just look on these things. These are potentials, different potentials, after adding certain amount of solutions. These are good. Always titration curves are looking like this. Here breaks are there. Equivalent points is there. The titration practical things not possible to explain you in theory. I think the chiller system, chiller compounds. And these are so indicators: indigo tetrasulfate, methylene blue, diphenylamine, barium diphenylamine. These are some indicators. Then redox titration in non-aqueous solvents. Criteria for solvent selection. So it is given here. The solvent should be resistant to the attack by the reagent. This permits reactions to be carried out over a wide range of potentials. So precautions are there, not so much important. Common non-aqueous solvents name: acetic acid, acetonitrile, dimethyl formamide, dimethyl sulfoxide, like this. Then oxidometry reagents. Oxidimetric reagents are potassium permanganate, KMnO4, dichromate, K2Cr2O7, cerium 4 ion, potassium dichromate, potassium bromate, KBrO3. These are some of the potassium iodide are called oxidimetric reagents. They are all oxidizing agents. They are all oxidizing agents. Yes.
So what type of questions come in exam from this unit?
It will come, you can see it will come just like this. I can show you the question pattern. They will ask this question like, first of all, one thing question will come, how to calculate E cell, E0 cathode minus E0 anode from the Nernst equation. That question you get it. Then also they will write an equation and you have to say which one is reduced, which one is oxidized. And third one is that you can see here, question number 7. A reaction is given there, E0 MnO4 minus Mn plus 2 given, E0 Fe plus 3 by Fe2 plus given. So you have to see here that first of all which one is reductant, which one is oxidant. Then we have to calculate the oxidation number. For example, in MnO4 minus, Mn is in plus 7 oxidation state. And here right side Mn is plus 2. So plus 7 to plus 2 means plus 5 electron you gain it. So it's a gain of electron, that means reduction. So Mn plus 7 to plus 2 is reduction, and Fe2 plus to Fe3 plus is oxidation. So E0 cathode equal to E0 cathode minus E0 anode. It means 1.52 minus 0.07. But here you see it that it is a balanced reaction. So E0 E cell equal to E0 cell minus 0.059 by N. Here N equal to how much? You have to simply balance this equation to calculate the number of N. Just I told you, Mn upper minus, first of all Mn2 7 plus to Mn2 plus 5 electron, then Fe2 plus to Fe3 plus 1 electron. So you have to balance it by multiplying 5. So 5 is the N here. So E0 E cell equal to 1.52 minus 0.77 into how much? 0.0591 by log Fe3 plus concentration by your Mn plus 7 concentration, A into B, this equation. This equation to put it. The dual equations. These are equations you can see. This one. This one, redox iterations. E cell. E cell equal to E1 and E2 to calculate. Then you differentiate E2 minus E1 and you get the value of it. That question will come. Then one more thing is which type of indicators are used for which type of which type of compounds. For example, they will ask you that if the indicator is diphenylamine, then what its color changes? Eh, it is from colorless to violet. Means the type of color changes or whatever it may be, depending on the indicators used. That question will come. Then it will come also some non-aqueous solvents के नाम बताओ, वो भी आ सकता है. You can see here some questions you can see here. But mainly here you get a definite one question, that is the calculation of redox potential or cell potential of a electrochemical cell. That question definitely will come. Yes.
And sir, what about practical exams?
Yes. Practical
When
exam, I think it will be done at the level of the regional director office. I will
oh,
be there also, I think. Only viables will be there. In a record, you have to write the 2 or 3 experiments of each unit. Then it will be, you have to send it. It will be corrected. Then there will be viables in online mode or in physical mode. If they ask it, they have to present in physical mode and come in physical mode. Or they may attach one university or a government college in Odisha where you can also come for practical examination. But it is not so problematic. You write the copy, a practical copy, and you attend the exam date. That's all. You get a good marks.
okay, sir.
Nothing to be worried
My
about this.
regional center is Delhi.
Yes, yes. Here,
My regional center is Delhi.
oh, Delhi. I think
So,
this is happening everywhere. Okay.
okay, sir.
They are giving good marks without any problem because actually saying there is no practical. If there is no practical, this is simply uh, not able to understand. Okay, but anyway, okay. Next we'll go to next one, uh, unit 11. Or unit 11 tomorrow we'll start. How many classes now? Only I think 2 more classes, na?
Yes, sir. Tomorrow and day after
Uh,
tomorrow.
then 2 classes we have 11, 11, 12, having 4 units are there. We'll discuss slightly. This is called complexometry titration. Titration is very important actually. Complexometry means you are adding a complex, and complex will form a chelate with the compound. And from chelating, the concentration is decreased. And then this measuring change in concentration will give you a graph. And graph will analyze you which type of compound it is. And also it depends on the ligands. Bidentate ligands, tridentate ligands, then chelate ligands. If ligands are strong, then they can form a strong complex. Strong complex means a strong coordinate compound. Strong coordinate compound means its concentration is decreasing completely. Then also you can accordingly the concentration if is decreasing, then from the graph also you can able to know जे कितना बड़ा कितना कम है. You can see here EDTA is a what complexing reagent. You can see EDTA is there, Then you can see some ambiguous ligands are there. Nitro nitrite attached to nitrogen is nitro, attached to oxygen is nitrite. Then you can see the chelate ligands, DCTA, DTPA, ethylene diamine tetra EDTA. They're all because they can form a ring compounds. And ring compounds are very stable compounds. That is there also. Ring compounds are very stable compounds. Then metal ligand equilibriums. These things we'll discuss also. You can see one thing here. You can see here copper reacts with ammonia. For
नहीं सर,
ammonia,
स्क्रीन शेयर नहीं किया,
yes,
स्क्रीन नोट ऑन.
screen not shown. Okay. Okay, sorry. Now you can see.
यस सर.
Yes, you can see here. Just yes, complex symmetric titration means, as I've explained you, that whenever you
Yes.
are doing titration, there will be a metal ligand complex formation, and this complex formation is an equilibrium reaction. The basic principle is that metal reacts with ligands to form a complex. For example, you can see here ethylene diamine tetraacetic acid, or called EDTA, is a complexometric reagent. You can see this. So here we will discuss about metal ligand क्या होता है, इसके अंदर में मतलब how many metal मतलब stability कैसे, जो मैंने बोला जैसे कि if it is a chelating ligand then stability is very high, if it is a weak ligand then stability is very low. Depending on stability, the potential the titrations value will also different. You can see here metal ligand complexes. Copper 2 plus 4 ammonia, CuNH3 whole for 2 plus. It is a copper tetraamine copper 2 complex. Means copper अब बाहर नहीं है, कॉपर से 4 जो लिगैंड से वो घेर के रुए हुए उसके हैं. जैसे कि आयरन के साथ 5 कार्बन मोनोक्साइड FeCO F, it is a neutral complex. The first one is a cationic complex. Ligands बहुत ज़्यादा different type होता है. All the negative ions are ligands. Cl minus, Br minus. इसका oxidation number भी calculate होता है depending on their charges. Ethylene diamine is a neutral ligand. Ethylene diamine is a neutral. EDTA is a tetradentate ligand. You can say denticity. You can see here, you can see this one, EDTA, CH2CO minus, CH2CO minus, or you can say CH2CO minus, CH2CO minus. So 4 different sites are there which will attach to the metal forming a ring complex, or you can say a chelate complex. Then if any ligand are attached on both sides, it is called as the ambidentate ligand. These are the chelate compounds. Understood, Jitendra?
Yes sir. Mostly in industry use EDTA.
Yes, tell me.
Industry use mostly EDTA.
Mostly because EDTA is cheaper.
Yes sir.
And second is EDTA, the peaks are very sharp. In NMR spectroscopy, if you see, its peaks are very sharp. See, if a sharp peak is there, then only you can understand the its reaction with the complex, its ability to convert a compound into complex. Everything is there. It depends on sharp peak. Sharp peak indicates many informations. If it's a broad peak, then it is very difficult to understand whether the reaction has taken place or any other solvents has interfered the reactions. Ethylene diamine also used, and one more is that it is called as what oxalic acid is also used. CO minus, CO minus, oxalate ion.
In my industry, I use mostly EDTA.
Uh,
I use titration calcium and magnesium.
yes, calcium and magnesium. Yes. So calcium,
So,
magnesium, it is used to remove the hardness of water. Sometimes it is also used. As you know,
yes sir.
seawater contains the hardness. To remove the hardness also sometimes complexing agents are used and the EDT is used. I think so.
Yes, sir.
It is good. You can participate because main thing is the here your participation, your questions, my answers. Otherwise, it is very much boring to explain all these things. You can see here formation constant Kf is very important. Kf value is very important. If Kf is high, then the compound is very stable. These things are there. You can see cadmium 4 plus formed with ammonia, but first one is only one ammonia, then two ammonia, then three ammonia, step by step. Then each step you have called stepwise formation constants. If you multiply K1, K2, K3, K4, then you get cumulative formation constants. And these formation constants explain each called as beta. And this beta, if beta value is more, then it is a good complexing agent. Sometimes you see the paint industry where the paints are produced, they use complexing agent. Because if you use good complexing agent, for example, Asian paints, some colors you have seen 8 years warranty, 10 years warranty. That means these colors, if you put in the wall, then it is not going to be removed easily. Because as you know, because of rainfall, many acids, water, all these things are there affecting the color. Like if the bond is very strong, that means if you are using a complexing agent, then this complexing agent will form the bond with the wall itself, and it stick to the wall so easily and firmly. So it is difficult to remove by simple rainfall. This is called as the complexing agent, and its value of beta. Beta is the cumulative formation constants. If it is a good complexing agent, means beta value is very high. I see. It is written here. Ligands, metal ion. If metal ion is a small ion, then it has very good complexing. Ligand, if it is strong ligand, then very good complexing. If the ligand is basic, then it is also very good complexing agent. If it is chelate ring size, ring 4 member, 5 member, 6 member, 6 member rings have most stable. Then chelate formations, number of metals in the chelate, resonance effect, steric effect, all these things are actually contributing towards the formation of metal ligand complexes and their stability. Questions will come from this also. Then you can see here principle of complexometric iteration, choosing a suitable complexing agent, a suitable method of detecting the end point. All these things are there. Yes, it is your work. EDT has come. EDT. You can see how they are added. See, whenever chemical kinetics means what? Means whenever you are adding two reactants into a reaction, when the reaction takes place, there will be a change in concentration of reactants and products. But from that you can draw the graph and you can plot it and you can know the result. Okay, you see here the values are given here. K value given here. Various ions are there, their K values. EDT titrations and pH relationship.
Sometimes to maintain pH, we use NOH.
Ah, yes. These things are very technical things are written here. Effect of other complexing agents. Here ammonia with zinc 2 plus. You can see metal EDT titration curve. Each titration curve looks like this. And the breakpoints are there. These things are there. We can discuss in the coming class. Okay.
Okay, sir.
So now I will end this class. Okay.
Okay, sir.
Okay, thank you very much.
Thank you, sir.
Tomorrow we'll discuss. Okay.
Okay, sir.